Today we are starting with the some set of questions which are mainly based on like initial topics of your inorganic chemistry, like small bonding concepts and some of the periodic table concepts. Okay, so let us start this session. Students, start solving the question. You can ask the doubts or you can mention your answers, whatever you like. You can use the chat box. For question number 1, the question is, for which of the following compound the value of delta HF is negative only due to its lattice energy? Okay, I'm getting answer in the chat box. Other students try this question and reply. Any hints? Any student want to explain what answer is correct? And any hint for the question? The question is asking that delta HF is negative for the formation only due to its lattice energy. So we have to actually see what are the energy changes, enthalpy changes are associated with the formation of these ionic compounds. Okay, and in that we have to judge that the various energy changes in which only the lattice energy, delta H lattice energy, is negative. That is the only energy change which is negative in sign. Okay, that means other energy changes are endothermic in nature. Okay, clear? This is the question. So if we see KBr, for example, or NaCl, the changes are like sodium. This is delta H ionization energy, which is endothermic. Okay, so this is the process which is endothermic. If we convert this Cl2, half Cl2, first of all, we will break this into chlorine gaseous atoms and then electron gain enthalpy. This is the delta H electron gain enthalpy, which is negative in sign. So this is positive and this is negative. So this will not be our answer, because when Na plus and Cl minus will get combined, delta H lattice energy will be negative, but the only reason for delta HF is negative is due to lattice energy only. None other factor will come as negative. The purpose of the question is this. So in case of KBr, NaCl, CaF2, the exothermic processes are F2, F minus, Br2, Br minus, Cl2, Cl minus. These will be the exothermic processes, right? Because they are electron gain enthalpies. But in case of MgO, because we have to form oxide, and formation of oxide like O to O minus will be exothermic, but O minus to O2 minus is highly endothermic. So this overall process is endothermic. O to oxide formation is endothermic. This is endothermic. Delta H is positive. So now, in case the value of delta HF is negative, that is the case because all these ionic compounds have delta HF formation negative, only due to lattice energy, the answer will be MgO. Okay, its answer will be A. Here, any doubt in this case? Let us move to the second question, which is very straightforward answer. Sometimes direct results can be asked. The correct order of increasing electron affinity of the following element is. Please tell the answer fast. Be quick. I'm getting the answers in the chat box also, but I need some more results, some more answers from the students. We are having ample of participants here. So please, you have to just reply your answers or just message your answer in the chat box. So just to confirm that you are participating. Okay, very good, very good. Yes. So now maximum students are replying and their answer is also coming correct. Yes. Okay, so answer is A. Okay, the correct answer is A. OSFCl. See, oxygen and sulfur, fluorine and chlorine. In this the electron affinity order between the second period elements and third period elements, which we compare, third period elements have more electron affinity than the second period elements due to their more size. They can easily accommodate the electron, incoming electron. Okay. But when we are comparing OSFCl in a combined form, chlorine is the highest electron affinity having element, then fluorine, then sulfur, and then oxygen. So these are the actual order when we compare them combinedly, OSFCl. Okay, you have to remember this result, which is very simple result, because S will be more, Cl will be more. When we compare between S and F will be more. Okay, the result you have to remember. Okay, so correct answer is A. Okay, let us move to the next question. Which of the following species has a maximum number of different types of adjacent bond angles? Okay, try this question. Okay. Again, like the previous question, students, please message your answers, and then if there is any requirement of the discussion, you can ask. Okay. Okay, Ashutosh, Manvit, answer. Your answers are not matching, Ashutosh. Please try once again. Okay, okay. Students are answering. Some of them are giving answer B. Shija is giving answer A. Okay, Ved Prakash is giving answer C. See, this is a very simple question based on the bonding. First of all, we have to check its correct bonding structure. Like xenon OF2, it will be like this. Xenon O2F2. First of all, let us draw their structures. Now, how many different type of adjacent bond angles? See, we have to think of adjacent bond angles. So let us try. This is the adjacent bond angle theta. This is of only one kind. Okay. In this situation, adjacent bond angle will be like theta1, and between oxygen, it will be theta2. In this situation, we'll be having FCl as theta1, ClCl as theta2. This is ClF as theta3, and this FF as theta4. Okay. These are the adjacent bond angles. In this situation, this will be theta1 and this will be theta2. Any doubt in this case? Now the answer will be C. Okay. Some of the students have got the correct answer. Okay. Let us move to the next question. Okay. The instruction for the questions, it is single choice correct. Till question number 10, it is single choice correct. Okay. Some of the students are getting answer C, some are getting D. Okay. Ashutosh is also getting D. See, the concept behind this question is that XZ and YZ are the nodal planes of a particular d orbital. So that d orbital is actually dx1. And now you have to find the, first of all, the hybridization of these species. So hybridization of IO to F2 minus is sp3d, ClF4 minus is sp3d2, IF7 is sp3d3, and SF6 is sp3d2. Okay. So in case of sp3d, dz square is used. In case of d2, dz square and dx square minus y square is used. In case of d3, dz square, dx square minus y square, and dxy is used. And again, dz square, dx square minus y square is used. So only in this case, dxy is used in the hybridization. Okay. Again, read the question. The d orbital having xz and yz two nodal planes, that is dxy, is involved in hybridization of central atom of which of the following species? The answer is C. Okay. So some of the students which are not getting the answer C can ask your doubts. Now clear? Ashutosh, Samarth, Avinash. Clear? See, we can sometimes judge it that which type of orbitals can be used in hybridization. Like in case of S3D, we have to make a trigonal, planar, and then bipyramidal situation. So if we fix like that, this is the XY plane, as this is the XY plane. So we consider it as SP2, and S plus PX plus PY, we consider it like this. And to go in the perpendicular direction, we use PZ and DZ square. Okay. So like this, we can bifurcate. Now, in case of octahedral situation, we have to make a square and bipyramidal. For square, we can use S plus PX plus PY and DX square minus Y square. And for perpendicular, we can use PZ, DZ square. Okay. This is to just remember, it is like a trick based situation. How we are remembering that how much orbitals are being used. So in case of sp3d3, we have to draw a geometry which is actually pentagonal bipyramidal. So to increase the number of bonds in the xy plane only, now we will be using dxy also. Okay, with respect. So basically in these three cases, we can judge. To go in the perpendicular directions, we are using dz square. To remain in the xy plane, square pyramidal or pentagonal bipyramidal, trigonal bipyramidal. So what is the case in this situation? In this situation, it will be dx square minus y square only. If you are making it a square pyramidal. Okay, fine. DSP3 will be square pyramidal, and in this situation, we will be using dx square minus y square. Okay. Okay. Any other doubt in this situation? Let us try for the next question. Okay, students have started answering. See, with Prakash, there is a case in which there can be two possible geometries, DSP3. It can be a TBP geometry also, trigonal bipyramidal geometry also, and a square pyramidal geometry also. Okay. If we are having a SP3D or DSP3, we can have a case of TBP geometry also. In this situation also, SP3D and DSP3, we can have a square pyramidal geometry. The difference in the participation of d orbitals will be here dz square will be used in both the cases. This will be used for inner, this will be used for outer. And again, in this situation, x square minus y square will be used. This will be for inner orbital complex, and this will be for outer orbital complex. So, what is the answer of the question? Avinash is saying A, Ashutosh is having B, Raman Bhavan is having answer B, Manvita is having answer B. The confusion is between N2O4 and N2O3, right? So in case of N2, just go by the bond order. In case of N2O, this will be the compound, which can be written as N triple bond and O minus here plus. And due to that resonance, that will be having a lesser bond order. Right? The bond order will be in between 2 to 3. decrease in the bond order will increase the bond length. In case of N2O4 and N2O3, the bond order is actually same, and bond order is same, but there is a difference of one lone pair. So in the situation where a bond pair is replaced by a lone pair, we can consider as its percentage S character is increased, and here due to that its percentage P character will be increased because the nitrogen will balance this S character through its increase in the P character. So lone pair occupies more space. By VSEPR theory also we can judge. So due to repulsion, that bond length increases. Okay. So N2O3 will be having more bond length than N2O4, NN bond. Its correct answer will be A. Okay, so you can use that percentage S and P characters explanation, or directly you can apply the VSEPR theory. By lone pair repulsion, bond angle will get decreased and bond length will get increased. You can take an example, a smallest example of CH2F2. Here all the bond angles are not same, like CH4. So in this situation, the bond pairs are more towards fluorine, and here somewhere in between. Okay. So more repulsion will be between these bond pairs. Let us say this bond angle is alpha and this bond angle is beta. Okay. So alpha is the increased bond angle than 109. This will be 100 and greater than 109 28 minutes, and this will be less than 109 28 minutes. Okay. If they are not having exactly same bond angles, then S and P characters are not same in all the bonds. Okay, we can relate it directly by the your hybridization of methane. Okay. So by this situation, we can judge that the percentage S character will be more in this situation, and here percentage S character will get decreased, but percentage P character will get increased. This is only the bench rule. You can apply it wherever the deviation of the bond angles are present, or if we are comparing a situation in which central atom is having hybridization same, and we are having different type of surrounding atoms. Now in this situation, the percentage S character is increasing, and here due to lone pair, because lone pair, due to lone pair, it has more bond angles. We can say it has a more tendency to occupy space on the central atom, right? Due to that reason. So bench rule you have to actually use in the limitations of VSEPR theory only. Okay, that is a replica of VSEPR theory only. Okay, let's move to the next question. Try this. Question number 6. Yes, Raman Bhavan is getting the answer C. Sorry if I pronounce the name differently, or whether it is your actual name or not, but the ID from which you are messaging, I'm telling that name. Okay, so correct answer is actually C. Yes, now Manvitha has changed the answer. So finally, answer is C. See, you have to check only the bond orders in this situation. Okay, so in case of H3BO3, the bond order will be 1.33. In case of BOH4, the bond order is 1. In case of BOHCH3, see, BOHCH3, this is the compound in which there will be a back bonding. So due to back bonding, its bond order will be like 2, because it will not be a sharing a case like H3BO3 will be sharing that pi electron density with 3 oxygens, right? In case of BF2OH also, they will be sharing that pi electron density. So again, the bond order will be 1.33. Here bond order will be 2 because this pi bond is not getting shared by other elements, because methyl will not be participating in the back bonding. Okay. So correct answer is C. Any doubt in this case? Now clear? Ashutosh, Avinash?
In BF2OH, can we say that BO bond has more S character?
Yes, you can apply Benz rule over here. But that first of all, we have to check the bond order. The main result will come due to bond order. Bond order is having a difference. Okay. Okay, with Prakash. Yes, we can compare between A and D. Extent of the back bonding will be, in that case, will be more in the BF2OH of that fluorine. We can say that back bond strength will be more in case of BF2OH, because fluorine is small in size, so it can form a stronger bond. So in that situation, when one OH will be replaced by F, the percentage of P character will get increased. In case of BF bonds, and percentage S character will get increased in BO bonds. Okay. So in that situation, that BO bond will be shortest in case D. Okay. See, here the back bond extent comes more for fluorine rather than oxygen, because a smaller size of fluorine. Okay. If we compare like BF3, strength of back bond is more in the case of BOH. Here we do not use that donating capability, like O is less electronegative. In this situation, the back bonding is better in case of BF3. The extent of back bonding is more. Okay, bond orders are same, but size of fluorine atom is less than oxygen atom. Okay, so either this factor or that donating power factor can be used, but which is dominating is the size factor of these fluorine and oxygen. Although not very much difference between F and O, but the extent of back bonding comes better in case of BF3. Yes, Avinash, you are getting answer correct. And Manvitha, no, your answer is not coming correct. Sheikh Mastan Jilani is getting answer correct. Okay, give one more minute to this question number 7, then we will respond. Students, please reply what answer you are getting. Yes, when we will be comparing the situation like this, like BOHF2 and BF3. See, one fluorine has replaced by OH. So here bond order is 1.33, and we can say that hybridization is sp2. So percentage S characters are same, like 33%. But if fluorine is more electronegative than oxygen, oxygen is less electronegative. So here percentage S character will come slightly greater than the case of BF bond. Okay. So now in this situation, the percentage S character here in the BOH bond will be greater than 33%. Again, the extent of back bonding will come in case of BF3 more as a whole compound, because as percentage S character are increasing, back bond its strength will be increasing. like S character will decrease as percentage S character decreases, back bond strength increases. But here the percentage S characters are actually increasing in the BOH bonds. Okay. Yes, again, if BOH3 is there and BF2OH is there, BF2OH will be having more strength of back bonding. But now what we are comparing in that, in BF2OH and BOH3, what we are comparing is strength of back bonding or bond length. What we are comparing? We want to compare like BOH is there and BF2 and this OH will be there. Now we have replaced BF3 by 1 OH. So here percentage S characters are 33. Here percentage S character will be increased by, like, this will be having X by 3. The contribution of percentage S is 33. And if F is replaced by 1 OH, here percentage S character will increase in this situation. Okay. So back bonding strength will decrease. And again, if both of these OH, now again, this S percentage S character are 33%. Okay. So now percentage S characters are here 33 and here percentage S characters are greater than 33. Right. So here back bonding strength will come less. So bond length will be more in this situation. Okay, because back bond strength will come less, extent of back bonding decreases, bond length increases. Okay. We took it this as a reference that we are having 33% S character. When we jump into this situation, we are having more percentage S character, greater than 33% in this situation. Okay. But back bond strength actually decreases when S character increases because the holding power of element also increases. So if bond length decreases, but main is the extent of back bonding, right? The bond length is decreasing more due to that pi bond character which are coming due to back bonding. If here this is doing back bonding in a proper manner, and in this situation the back bonding is not coming in a proper manner, so pi bond characters will come less. Okay. Fine. Okay. Now any inputs for question number 7? Okay. See, what answer I'm having for this question as a correct answer is, its answer is actually C. Now, because we are comparing between these 3 species only, no other species is given. Let us compare by their bond order, because bond order is asked and bond length is asked. So what are the bond orders here? Bond order is 5/4 of the PO bond only. Like in HPO3 2 minus, we will be having the bond order as 4/3. And here we will be having bond order of the PO bond as 3/2. Okay. So these values are 1.25, 1.33, 1.5. Okay. So bond order is having the order PO3 2 minus, HPO3 2 minus, H2PO2 minus. Okay, so bond order is given wrong. Again, the bond length will be opposite of this. So again, bond length is also given wrong. And reducing character depends upon the non-ionizable hydrogens. So these are having more number of non-ionizable hydrogens. So reducing character will be like this, which is also given wrong. Okay. Yes. So correct answer should be C. Let's check it again. We are here comparing the bond angles. Here the bond angle will be 109 in the first case. Okay. The bond angle here are 109. In this situation, we are having pi bond characters and that single bond hydrogen. So here bond angle will be greater than 109. So between PO bond, the bond order is actually increasing. So mutual repulsion will be greater than the previous one. So here the bond angle will further increase. Greater than 109, we can say. Okay. So this is the correct option. Okay, let us move to the next question. Now the question is SO terminal bonds, not the middle bonds if they are coming, not identical. See, these are in resonance. They will be having equal bond orders, 1.5 and 1.5. Okay. In this situation, it can do resonance with 2 pi bonds. The bond order will be 5/3. Here the bond order will be 1.5. So here it is coming different. Different bond orders are coming. So answer is B. Okay. Here they are coming exactly same. Similar type of terminal linkages are there. In B situation, the terminals are not same in a manner that it is not having SOS linkage. Sometimes in a hurry, we can do this type of mistake, making it symmetrical one. Okay, so this is the wrong structure of pyrosulfate. Okay, this is wrong prediction. You can mistake over here. Okay, let us move to the next question. Okay, its correct answer is actually C. Any doubt in this situation? Avinash, do you have any doubt? Okay.
D option, can you explain why wrong, sir?
D option.
Why is it wrong, sir?
Okay. See, in this situation, we are having OCl2 which is sp3 hybridized. Okay. ClO2 is sp2 hybridized because in this situation, that odd electron do not participate in hybridization. Okay. That odd electron did not participate in hybridization. So sp2 and sp3, sp2 will be having more angle, bond angle. Okay.
Okay, sir.
Okay. Question number 10. Okay, okay. I'm still getting the inputs from the students. See, in SF6, 2d orbitals are participating in hybridization. That is correct because those d orbitals are dz square, dx square minus y square. Okay. D orbitals are participating in hybridization. 2d subshell are participating in hybridization in SiF6. So orbitals and subshells mean d subshell means all 5 orbitals compile of 1d subshell. Okay. So this statement will become wrong. This is d subshell. and this is orbital. Okay. Now, in third case, the coordination number is 6. These in this situation, like 10 electrons are present in the d orbital. So d orbital cannot occupy 10 electrons. The question is actually having the language default. An orbital cannot occupy more than 2 electrons, right? So again, third statement is also false. The actual thing is total d orbitals it should write, or it should write d subshell in this situation. Here it should mention the subshell, then it is correct. Here it should mention orbital, then it will be correct. All three statements will become correct if in second we use d orbital instead of d subshell, and in third we use d subshell in place of d orbital. Okay, so correct answer is B only. So there is only a term confusion in this situation, not a very big concept. Only the term confusion can make this question wrong. Okay. Come to the next question. This is more than one correct. Try this one. Okay. Very good. Yes. Very Raman Bhavan, Ved Prakash are getting correct answers. Okay, Samarth. Okay, Vinash. You, Samarth and Avinash have missed one options, like Samarth answer is ABC. Avinash is having ABD. Some are having AC and some are having all ABCD. So different inputs are there. Now Avinash has changed the answer. Now the correct answer I'm sharing with all of you is, the correct answer is ABCD. Okay. Any doubt in this situation? You can ask. See, the z-axis is the internuclear axis. This carbon is having hybridization sp-z. sp-z. Because the internuclear axis is z. And the pi bond will be formed by px and py. Okay. So CO pi bond is formed by overlapping of 2px with the 2px of oxygen atom. And another pi bond will be formed by 2py with 2py of oxygen atom. Nodal planes of both pi bond passes through z-axis. Okay. The px overlapping and py overlapping. You can imagine it like this is x. So this is z, like internuclear axis. This is x, this is y. Okay. So the both of the pi bonds will have the nodal plane into z-axis. 2pz orbital participates in hybridization. Okay. That is the statement given due to internuclear axis. Here you can make small mistakes, because the question is very easy, straight. Sometimes we think that language problem is there. and might be something is missing in this situation. So you can reattempt the question. It will take hardly 30 seconds, 1 more minute. But in such situation, you can actually check the ambiguity where it is present. So nodal planes, you can recall 2pz orbital of the carbon participant in hybridization. Sometimes we see that internuclear axis is x-axis and spx px orbital participant in hybridization. So the condition is given already that it is z-axis, which is internuclear axis. Okay. Let us move to the next question. So maximum students are saying the answer is BC. Okay, D also. BCD. All oxygen atoms lie in the same plane. Okay, correct answer is B, C. Okay, anyone is getting answer D can explain why they are getting the answer D. It will be like this. See, this is planar. And in the tetrahedral geometries, we can have two valencies in the same plane. Right? But in case of SO3 2 minus, it is not planar. And we can maximum have two oxygens in the same plane. The other will be due to that pyramidal formation. Yes, they are not asking about the central atom. Yes. They are asking about all oxygen atom lie in the same plane. Okay. No, it is not necessary. Okay, okay. It is not necessary that the plane passes through central atom only. Okay. So in that situation, you are thinking like we are having this oxygen here. They are forming a pyramid, pyramidal form, and at the base of pyramid, the three oxygens are coming, right? Okay. Then what about SO4 2 minus? It can also have three oxygens in one plane. Finally, it will be like this. Okay, we can form a base over here, and that pyramidal one is okay. All oxygen atoms lie in the same plane, right? Right. So fourth one will be off plane, right? Okay, so A will not be the answer, and its correct answer is B, C, D. Okay, because the central atom is not associated, the correct answer will be B, C, D. Okay. Now, any doubt in this question? The final answer is B, C, D, because that pyramid can have that plane oxygen atoms. Those who are getting answer B, C, now justified with these statements, answer will be D also. See, the correct answer will be, let us first discuss the points like X1 and X2. These bonds are not having any resonance. They are not having any resonance over here. And the central atoms are also not same. So because that boron and carbon, the carbon is smaller in size than boron. Okay, so size of carbon is small, therefore that CC bond will be smaller than the BB bond due to the size factor. Because the atoms are not same, we will not going to apply any rule over here. We will just check the size of atom. So the bond length BB is more than CC. So A is correct. When we compare between Y1 and Y2, see, in this situation, the proper resonance is there, the participation of anion, proper resonance is there. Here we are having back bonding. Okay. So the proper resonance is the pi bond formation density will form the actual pi bond characters more than the back bonding. Okay. So in this situation, the BF bond will again be greater than a CO bond due to that bond order, we can say. The bond order will be slightly more in the case of Y2 because that is proper pi bond formation due to resonance. In the back bond tendency is a slight lesser tendency. So we can say that whenever we are forming the actual pi bond, that the extent of overlapping is more than the back bonding. So back bonding is a weaker form of pi bond, we can say. Back bonding is the weaker form of pi bond. So in case of BF bond, it is a weaker form of pi bond, therefore its bond length will be more. In case of theta 1 and theta 2, again that repulsion factor will come if it is a proper pi bond, if it will be having the double bond characters more effective. So in this situation, the bond angle will get increased. So theta 1 will be less and theta 2 will be more. And now we have to compare X1 and Y1. This X1 and Y1, again by the size factor, we can say that X1 is greater than Y1. Because this is the BB bond and BF bond is also having the smaller F atom and back bonding also. Okay. So answer will be A, B, and D. Okay, any doubt left here? First, between X1 and X2, we are comparing just the boron-boron and carbon-carbon size because no other factor, no other can come. In case of Y1 and Y2, we are checking the extent of bond, which is better. So normal pi bond is stronger than back bonding situation. By that difference, we are comparing C option also. And between X1 and Y1, again, the size factor and again the back bonding consideration between B and bond. Okay. So some of these students were getting CD, ABC, only B. Now correct? Now any doubt left? Let's move to the next question. See, the question is very simple. Again, you are getting confused in the term. Sometimes we do not expect a very easy question in the advance, but here it is asking that first ionization energy is greater than the second ionization energy. Actually, it never happens for any element. When A converts into A plus, this is ionization energy 1. And when A plus converts into A plus 2, this is ionization energy 2. Then ionization energy 2 is always greater than ionization energy 1. Always. Not a single exception. Okay. So its correct answer is 0. We even do not need to write the electronic configuration of anything. Okay. Irrespective of any electronic configuration, this order will always get followed because Z effective increases. Number of electrons are decreasing. So effective nuclear charge is increasing. Order of Z effective is A, A plus 2. So ionization energy will definitely increase after removal of one electron. Okay. Attempt next question. So the question number 14 was just to confuse you during the paper, and in a hurry we can start writing the configurations over here and start comparing the stability of electronic configuration half filled full filled is actually not required. Okay, try for question number 15. Yes, with Prakash, your answer is correct. Samarth answer is correct. Vamsi Krishna, 4 is not correct answer. Recheck. Yes, Sheikh Manvith getting correct answers. Okay, the correct answer is actually 3. Okay. The question is asking that total number of molecular species in which central atom carries 2 lone pair. So number of lone pair on central atom they are asking. In NH2 it is 1. In SF4 it will be 1. ClF2 it will be having 2. ICl4 having 2. Xenon F2 is having 3. So 3 will be wrong. Xenon F5 minus it will be having 2 lone pairs. CH3 minus is having 1. This is having TEF5 minus is having 1. And BRF2 is having 3. Okay. So correct answer will be these 3 only. Okay. Yes. Answer is 3. Okay. Let us try for the next question. Okay. Because we have to check the 2 points. Again, the polar molecule species. So first of all, remove the non-polar species, and we are having as a non-polar species SiH4 and ICl4 minus. They are non-polar species. SiH4, ICl4 minus. These are non-polar. So first of all, remove these. Now check for others. NH2 plus. This. I think all will be having more than 50% as character. Any doubt in this situation? NH2 plus. See, in case of NH2 plus, the hybridization is sp. Okay. Any other doubt? Clear? Clear to all? Just reply clear. If you do not have any doubt, just reply for clear. No, with Prakash, not actually 50%. We are having the hybridization ICl4 minus as sp3d2. Okay, but actual P characters will not be exactly 50%. And in this situation, we cannot actually explain sp3d2 in that situation. Okay. sp3d2 is actually symmetrical now. And lone pairs are occupying opposite positions. The question is mainly not for the sp3d2 situations. It is like ruling out because of the non-polar situation. So if sp3d2 is there can be a confusion that exactly 50% less than or greater than how we will decide, but because it is non-polar, it is getting ruled out. Okay. Try for the next question. This is matrix match. And first matrix match, which is based on the PQRS code. Okay. The correct answer I'm having is D. Okay. So in case of H2, 3 its pyroform doesn't contain oxy linkage. This will match for it. Okay. So its pyroform will be H2S2O5. and this will be having the structure like this. Okay, so 3 will be considered for it. In case of H3PO4, among all of them, only the case which H3PO4 can match and others cannot match is it exhibits a reducing character because of that non-ionizable hydrogen. Okay. In case of H3BO3, again, whether it can react with NaOH or not, so it can react with NaOH. And in case of HNO2, it doesn't exhibit any tautomeric change. Pyroform means when two molecules H2SO3 and one molecule water is removed. It will be having H2S2O5. So this will be sulfurous acid. And this is sulfurous acid. Okay. Clear?
What is the tautomeric change?
Tautomeric change is like in this situation, like H3PO3 is there. So we can have its tautomer like this. If we remove the hydrogen, the ionizable H, see like this. POH, we are having H3PO3 as one of the structure, H3PO3. If we ionize this, H plus is removed. And now this lone pair gives electron to this H plus. And this forms a pi bond. Okay, so this will be the major product. And this will be the minor one. What we actually remember is that major product. But this compound and this compound can have a slight equilibrium with each other, and that is the tautomeric change.
H2SO3 can undergo this, sir.
Yes, H2SO3 can undergo this. The sulfur will give electron to this. And this pi bond will form. Okay, but again, this will be a minor form. And what we actually remember is this as the major form. That central atom must have a lone pair to give to H plus when we are ionizing that H plus.
Then why can't HNO2 give?
See, in case of HNO2, if we remove H and form it as O minus, that lone pair donation can take place. But that pi bond cannot form actually. So it will be highly unstable in that situation that the pi bond cannot form. So that H plus transfer cannot take place. Okay.
Okay, sir.
It cannot form that pi bond. Therefore, the neutral species is not getting, so it will not work out actually. Okay. 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 Attempt last question for today, question number 18.
Sir, PQRT, PQRS, PR.
PQRT. Okay. A answer is PQRST.
Yes, sir, PQRST.
Any doubt in case A? The answer is PQRST. Anybody needs explanation?
Can you explain p pi d pi bond?
Yes. This will be a p pi d pi bond. That pi bond is p pi d pi. Phosphorus is using its d orbital and oxygen is using its p orbital.
Yes, sir.
Okay.
Sir, explain the S ones.
Non-axial d orbital. See, in that situation, the hybridization is sp3. So in this p3, pz will also come and pxpr will also come. But after using that all three p orbitals, the d orbital which it will use for the pi bond formation, that is not the intermixed orbital. Na? So it is a pi bond formed by the d orbital of phosphorus. So which kind of a d orbital can form pi bond? Only the non-axial ones. Axial one dz square dx square minus y square can't form pi bond. So we will be having either dxy, dyz or dxz as the d orbital, one of them, any one of them for pi bond formation. Therefore, this option is coming non-axial d orbital participate in bond formation. Which kind of bond formation? Pi bond formation. I think the main confusing points were that non-axial d orbital participate p pi d pi bond present or not. Okay. Okay, guys. So can we end up the class here? You can mention clear and done, and you can leave the class. Bye bye. Take care.